Minor explosions on the sun could power the U.S. power grid for 180,000 years. Humans have always been fascinated by the sun, I think because it is so constant compared to our daily life. We don't see from Earth the seasons that it has. It has seasons. It goes through an 11-year cycle that changes its magnetic field, but we don't see that necessarily on Earth. So I think for humans, it's always been that bit of warmth, that steady companion that we've had throughout humanity. We do see the sun every day in the sky, but we don't know everything about it. There are still a lot of mysteries there in only our closest star. And those mysteries tend to be, A, why the outer atmosphere of the sun is so hot. B is it constantly throws off this wind. So it's constantly losing mass or losing weight, but it doesn't necessarily lose weight. It's on the worst diet ever, that it just keeps trying to shed the weight, but it doesn't seem to come off. The solar wind is this constant stream of particles off of the sun, and it creates the atmosphere and bathes all of the planets as it goes out throughout the heliosphere, which is the sphere of influence of the sun. So coronal mass ejections are a lot of material just coming off the sun at once, and the amount of material that's coming out of these violent explosions are equivalent to 80 million school buses coming at 1 million miles an hour off the sun towards the Earth and towards all the rest of the planet. So this is a very violent thing that throws off lots of energy and lots of matter outwards that can really affect things in space. Each of us are about stardust, and the calcium in your bones came from other stars. The oxygen that we breathe came from other stars. So all of these things came from other stars, including the material to make up the sun. So we are very intimately connected. I think that we are on the Earth on kind of this special sweet zone. They call it the Goldilocks zone when looking for extra exoplanets, planets outside of our solar system. It's that it's not too hot that you're not too close, and you're not too cold that you're too far away. You're in that Goldilocks zone. The sun itself is the producer of light and heat for the planet. And in that light and heat, it also then allows us to have breathable air, liquid water, and help us grow food. So all of those things are very important. And stars in general help us tell what the path was in the universe to get to where we are and kind of where we're going, the evolution. And in addition, they're inspirational. They are things that help us kind of take the step back and be curious and to get a little philosophical sometimes late at night looking at the stars.
It was really a wow moment. There was liquid water elsewhere in the solar system. We had been right. You have all of the ingredients that you need, that we know of, to develop life as we know it.
We have cleared the tower, and the Cassini spacecraft is on its way to Saturn.
So these sort of hard cases, these James Bond-looking cases, are used to transport the flight hardware. This is one of the magnetometer sensors that I worked on, and it will have been integrated onto the boom that came out from the side of the spacecraft.
And here's part of the magnetometer instrument, and here's the other half of the magnetometer instrument. This is a quarter-size model, so this is a quarter-size me. I'd like to be this weight, not this height.
She was one of the best things about the Cassini mission, because I spoke to her on the phone every couple of days for years and years and years. So a gas giant like Saturn is incredibly mysterious.
Saturn just captivates people because it looks so supernatural. It engenders the immediate feeling that it can't possibly be real.
It has no solid surface, and it has rings around it, and we don't necessarily know where those rings came from or how old they are.
These, as you can see, are spiky shadows that are created by these features here that are sticking up 2.5 miles.
Having the perspective of Cassini to be able to see that was one of the most extraordinary things, I think, about the images that came back.
It was just extraordinary. It was out of science fiction.
Some of the most amazing discoveries that Cassini made were about Saturn's moons. The first flyby of Enceladus was not terribly close, but something funny was happening in the magnetometer data.
Okay, so put it into slideshow.
My boss came to the team and said,
You can see there's a little pimple in the data, just over there.
"This looks intriguing. This is not what we expect. We expect on a rocky moon for the magnetic field to drape over it, a bit like a nice peaceful curtain draping over a window that's not moving. And instead it looks like there's some sort of breeze gently fluttering that curtain."
And what we were able to do is calculate what ions were generating those waves, and it was water group ions.
So Michelle decided, after discussions with all of us, that she would go to the Jet Propulsion Lab and she would propose moving the next flyby of Enceladus, which wasn't for some time to come, to much sooner. And this was a huge risk for her.
We knew for us to be able to have a chance of really seeing what was going on at Enceladus, we needed to get closer.
The principal investigator of the magnetometer, God bless her, she went into action and convinced the project to take the spacecraft close to the South Pole so we could all get a better look.
And I must confess, I didn't sleep for 2 or 3 nights before that close flyby, because if we hadn't seen anything, no one would ever have believed anything I said again. But what we found was spectacular.
This image made me nearly fall off my chair, because here we see dozens of jets, big and small, coming off the South Polar region.
It was fantastic. It was really a wow sort of a moment. There was liquid water elsewhere in the solar system other than the Earth. Enceladus, tiny rocky moon of Saturn, is geologically active. A stable liquid environment, organic material, and contact with rock, you have all of the ingredients that you need, that we know of, to develop life as we know it.
I love this picture, and it's about as much meaning as you can get out of the Cassini mission, because we know that that moon has an ocean in it that could harbor life.
One of the mysteries of Saturn originally was the source of the rings, and it turns out that Enceladus's geysers feed the very faint but very wide E-ring. It shouldn't be surprising that we found such interesting geological activity on a planet with 82 moons. Ironically, all these wonderful discoveries that we made meant you run out of fuel. It was on 1%, it had an empty tank, so we had to crash it into the planet and let it go.
This is the start of the end of the mission. We're running out of fuel, and we're going to make sure we go out with as much great science as we can.
We want to see how much of the atmosphere we can see before we lose the signal, before it can't fight the atmosphere anymore and it goes off point.
These last grand finale orbits where Cassini dove between the rings and the planet, they were never foreseen in the original mission planning. Actually getting to do that was really remarkable. Take these kind of dangerous dives between the rings and the planet to see what that space was like, actually with the spacecraft physically being there, was really remarkable.
In some ways, I just want it to be over now. You know, you're sort of waiting for it to end, and it's really weird.
Quite a lot of us were gathered round, tensely waiting for the data to come back. We were relying on the commands that we had written and we had sent to the spacecraft to have worked properly, and for the spacecraft to continue to be able to talk to us right up to the very last minute.
I can confirm science playback is locked.
And then it'll go away. We'll lose the signal, and that'll be end of mission.
Cross for 0 time.
So that would be the end of the spacecraft. Project manager off the net.
It doesn't feel a long way away, actually, because every time I watch it, I am immediately there again. So that I guess says something about the impact that the end of mission had.
That was a great spacecraft. It did exactly what we asked it to do, all the way to the end.
When you have checked on a spacecraft every day for more than a decade, and then suddenly it's not there, it really is a wrench. It's a blow, and you feel sadness and a certain amount of grief.
Godspeed, think it and release it.
Neptune. An ice giant, 17 times the mass of Earth. Over 1.5 billion kilometers farther from the Sun than Uranus, Neptune is almost chemically identical. Yet bizarrely, it couldn't be more different.
Neptune, in a way, was almost a relief because it wasn't featureless. You know, it's like, oh, good, a planet with clouds and features again.
Neptune was a great excitement. It's got swirling clouds, really strong winds. At 1,500 miles an hour, incredibly fast, the fastest winds that we've got in the solar system.
One of the things that Voyager discovered was an immense dark vortex within the atmosphere. A huge, swirling dark spot.
We say it's a giant storm, but just those words don't fully contain, we're talking about a storm the size of the planet Earth or larger.
And the surprises keep coming. Even though it's much farther out, Voyager discovers Neptune is warmer than Uranus. And the source of the heat is another oddity of this strange planet.
In fact, when we look at this dynamic activity in these extraordinarily cold regions, we really are at a loss to understand just what's going on here.
One theory is that the buildup of pressure beneath the thick layers of cloud turns the carbon and the methane into a rain made of diamonds. They then melt as they fall into the interior of the planet, producing the extra heat. As the heat makes its way out into the frozen cold of space, it churns the entire atmosphere, whipping up winds around the globe.
There are no mountain ranges, no valleys, no continental boundaries to get in the way of the perfect fluid dynamical flows. What that means is that when you start a weather pattern going, when you start a vortex spinning or you start a plume rising, there's very little to get in the way of it.
So those winds that develop and go around, they just keep going around and around. There's nothing to slow them down, no friction with the surface.
And the extreme cold here makes the atmosphere less viscous. Creating supersonic winds that outpace anything seen on Jupiter or Saturn. Voyager 2 has almost completed its grand tour. But before heading out into interstellar space, one last world awaits.
2,500-degree clouds filled with hellish liquid lava and 350-year-old giant megastorms. This is the most extreme weather in the universe. Saturn is the second largest planet in our solar system, and its rings make it instantly recognizable. And personally, it's my favorite planet because it rains diamonds from its clouds. Scientists estimate that around about 10 million tons of diamonds are produced in Saturn's atmosphere every single year. Now, the sizes of those diamonds could vary a little bit, but they're estimated to be about a centimeter across. That's the size of a 4-carat diamond. But why does this happen?
We know that on Saturn there's carbon soot. The carbon soot is created by lightning. Lightning actually zapping methane in the atmosphere. The carbon soot precipitates or falls through the atmosphere.
As the carbon soot falls from the clouds, this same crystallization process occurs, but instead of taking billions of years, it happens in a matter of moments. Now, in order for a planet to have weather, it needs an atmosphere, the layer of gas that surrounds a planet. So for example, Earth's atmosphere is made of nitrogen, oxygen, argon, and a little bit of water vapor as well. The planet Mercury and our moon, on the other hand, they don't have an atmosphere, hence why they look like grey, lifeless rocks. On Earth, a cloud forms where it's too cold for water to stay as a vapor in the air. Now that can happen with other materials too, just at different temperatures. So it's essentially possible to have a cloud made of anything. But what about planets that are so hot that things that exist as solids on Earth are actually liquids and gases in their atmospheres? I'm talking about things like rock and lava. Imagine it being so hot that lava evaporates into the air, forming clouds, and then you get lava raining from the sky. 55 Cancri E is an exoplanet that's about 40 light years away from us. It orbits really close to its star. Not only that, it's also tidally locked, which means that one side of the planet always faces its sun and it's always daytime there and it's boiling hot. The day side is permanently covered in an ocean of molten lava. It can be hard to picture what lava rain would actually look like, but volcanic eruptions here on Earth in places like Hawaii give us a hint of what it might look like.
Right here was the site of a massive eruption. All along this fissure, fountains of lava shot into the air nearly 100 meters high. The liquid lava droplets then cooled and solidified in the air before raining down onto the surface as these tiny pebbles. This is what we think the rain might be like on planets like 55 Cancri E.
Planet hunters and astronomers think they've found an exoplanet with the strangest rain in the universe. WASP 12b is an exoplanet 12,000 light years away. It's a gas giant like Jupiter, but it's twice as big and its atmosphere is 2,000 degrees hot. An atmosphere like that, we think the conditions would be just right to give us molten ruby rain.
And the way that it scatters light suggests that there are clouds high up in the atmosphere. At this part of the atmosphere, the temperature is around 2,000 degrees. So the most likely substance forming these clouds is an aluminium oxide called corundum, which forms the basis of rubies.
This crazy extraterrestrial weather doesn't stop at gemstone rain. There are planets out there that have the most gigantic storms that humankind has ever witnessed. We have Mars rover footage that shows us dust devils that are over 1 kilometer high. But impressively, the storms on Mars can reach up to 20 kilometers in altitude, and it's all down to Mars's atmosphere.
Its atmosphere is 1/100th the pressure of Earth's, and the effect of having that really low atmospheric pressure on Mars means that it can't trap any of its heat. So Mars is a cold, barren desert compared to Earth or to Venus.
The dust storms are so bad on Mars that every few years or so they engulf the planet for months at a time. That's going to have a major impact on any future human missions that we send to Mars. These storms on Mars, though, are minuscule in comparison to what's been observed elsewhere in the solar system. We've sent probes and satellites to all of the gas giants and found some mind-blowing weather activity. The Great Red Spot is a storm on Jupiter that is twice the size of the entire Earth. It was first spotted by Giovanni Cassini through a telescope in 1665, which means it's been raging non-stop for at least 350 years.
That makes it the longest living storm that we know of. The outer planets are big balls of gas, and that makes a huge difference in the weather because you don't have continents, you don't have mountains for the winds to rub against, and there's nothing to control the weather the way the continents partly control our weather.
Saturn is the planet with the largest and most powerful storm in the solar system, covering 4 billion square kilometers. And we know about it because we've seen satellite images of it growing.
On December 5th, 2010, the radio receiver on Cassini started picking up the radio signal of lightning. And on the same day, the camera saw a little storm up in the northern hemisphere of Saturn.
Within 6 months, the storm grew so large that it wrapped around the entire planet and its head caught up with its tail. The truth is, life on Earth is a huge anomaly in our solar system, our galaxy, and even maybe across the entire universe. The majority of other planets are a lot less inviting.
So the planets that we've found so far aren't particularly nice places to go. They're not somewhere you'll put on your vacation list anytime soon.
So while we might not describe weather here on Earth as mild all of the time, astronomically speaking, mild is the most appropriate word. What makes Earth so habitable is this perfect mix of conditions that we have that essentially make it like a Goldilocks planet for life. And that includes our proximity to our star, the sun. Any closer and it would be a hellish inferno, and any further away it would be a frozen wasteland. So it could just be a matter of time before we find a planet that's similar to Earth. But what we do know is that warm, cold, wet, dry, windy, and mild, all of these conditions work in perfect unison to keep us alive here on Earth. Essentially, we got lucky. So think about that the next time you want to moan about the weather.
What powers weather is very different depending on where you find yourself in the solar system.
The Earth's atmosphere and the weather on Earth is driven largely by one thing, and that's the sun. And the sun pours its energy down through the atmosphere, and it hits the surface, and the surface of the Earth then warms up.
With Earth, you've got all the energy coming in from the sun, heating up the surface, creating thermals that then drive the atmospheric flows that we see. Somewhere like Saturn doesn't have a surface to be heated up. So when you compare the weather systems on these giant planets to those that we have on Earth, you have to sort of tear up the rule book a little bit.
The sun is the great controller of Earth's atmosphere. But in the outer reaches of the solar system where Saturn lives, sunlight is 100 times weaker. It means some other heat source must be driving Saturn's incredible weather. As Cassini studied the cloud tops of Saturn, it was able to infer a huge amount about the truly strange world that must lie beneath, and the energy source that helps power this planet.
We had a whole variety of scientific goals at Saturn, and one of the main ones was to understand the meteorology of the Saturn atmosphere and what energizes the winds that we see on it and so on. And we have affirmed now the belief that atmospheric systems on Saturn are actually powered by energy from below, from an internal heat source on Saturn. They're not powered by sunlight like we have on the Earth.
Looking deep inside the planet reveals a heat source shaped by extreme pressure. Within huge clouds of water, Cassini records lightning 10,000 times more powerful than any on Earth. This lightning transforms methane gas into enormous clouds of soot. At 8,000 kilometers deep, the pressure of the atmosphere is 80 times greater than that at the bottom of our deepest oceans. Enough to transform this graphite rain into diamonds. But even these diamonds are likely destroyed by the pressures of Saturn, eventually dissolving. "30,000 kilometers down, and Saturn's heat source is revealed. Here, pressures are so intense that the atmosphere behaves like a liquid metal, able to conduct electricity. In this state, molten helium falls like rain. And as it merges with the surrounding material, kinetic energy is released as incredible amounts of heat. And it's this extraordinary heat source that helps drive Saturn's weather. Within just a few 100 million years of its birth, Saturn has witnessed great drama. Now it will remain largely unchanged for billions of years.